of a correct weight, width, and thickness. These furnaces heat the material to about 1200 degrees centigrade. 2 walking beam furnaces feed the material through the oven. The heating is especially important as it affects the properties of the material. If the material is not sufficiently heated, incorrect material properties will arise. This is due to carbides and nitrates failing to dissolve. During the heating process and the transport to the roughing mill, the hot material reacts to the oxygen in the air, and a mill scale consisting of oxide is formed on the surface. If the oxide layer remains on the material during rolling, the layer risks being rolled into the steel material, adversely affecting the surface quality of the final product. The material must undergo a mill scale cleansing before rolling. In order to cleanse the surface, water is sprayed at high pressure, 160 bar. After the material has undergone a surface cleansing, it's sent to the roughing mill. Here, the material is rolled from its original thickness of 22 centimeters down to about 3 centimeters. This is a very significant reduction. At this roughing mill, a powerful 4-high rolling mill is used. That is, 2 backup rolls and 2 smaller working rolls. The backup rolls are often cast steel rolls. The working rolls must have very smooth surfaces and tolerate high temperatures and wear, as they are in direct contact with the material. This particular material is rolled with 5 passes, where 1 pass means that the material passes through the rolls once. The material is surface cleansed several times during the roughing mill process to remove any new traces of mill scale. In order to control the width of the material, vertical rolls are used. The material is now called transfer bars. After the roughing mill, the transfer bar is rolled up in a coil box. The coil box's primary purpose is to save space, but when inside the coil box, a temperature equalization also occurs. The temperature difference between the ends of the material is minimized as the transfer bar is coiled together. When the transfer bar is removed from the coil box, it has a temperature of about 1050 degrees centigrade. The ends of the transfer bar are cut off, and the bar undergoes further mill scale removal.
5 forming rolls work like rolling pins to shape the welded steel strip into a curve. Each one bevels the pipe a bit deeper until the flat pipe takes on a U shape, about 70% of its finished shape. You can see they're the brightest spot in the factory, thanks to the continuous polishing effect. These rollers can be changed out quickly to run piles of different diameter or steel gauge, enabling our team to complete a drop-in rolling for customers with an urgent need. Finally, the rolling presses change from convex to concave and gradually push the ends together, making sure they line up evenly. And the strip edges are burnished clean to ensure a high-quality weld, the next step in the process. Atlas straight-seamed pipe piles are welded utilizing electric resistance welding. Abbreviated as ERW, this welding process utilizes 2 copper contact shoes to pass electrical current through the strip edges of the coil. Resistance to that flow of electricity causes heat to build up in the strip. The heat zone can reach 2,700 degrees Fahrenheit, all while the line is running at speeds of up to 120 feet per minute. The result is a continuous longitudinal weld with pinpoint accuracy, and the pipe is ready for finishing. Any excess seam from the weld is carved off by the scarf cutter, making a smooth and almost invisible seal. And then the pipe is ironed while the weld and pipe is still hot to get the right size and diameter for installation. After the ERW welded seam is complete, the pile moves on to ultrasonic testing. This test checks the integrity of the electric resistance weld and detects the presence of any internal flaws. Any defections are automatically cut out and part of the Atlas 100% quality guarantee. After weld integrity is confirmed, the pipe is cooled down gradually by a constant stream of water and coolant to prevent cracking or splitting. The Turk's heads work the pile to a final and precise size and a superior surface finish. Prior to cutting, there is one last